want to determine whether the following solutions are linearly dependent or not. So in this example, we're going to use the Wronskian test to check whether these solutions are linearly dependent or not. So I'm going to be evaluating the Wronskian of exponential minus x and 5 exponential minus x. So evaluating the Wronskian, on the first row I have the base form of the solutions, that's exponential negative x and 5 exponential negative x. Is that okay? So on the second row I'm going to have the derivative. Derivative of this is negative exponential minus x, and the derivative of this one is minus 5 exponential minus x. Now if you observe very carefully, you will discover that you can actually factor out, because exponential minus x is repeating. So in the first column now, exponential minus x is common, so I'll factor it out, exponential minus x. Okay, so factoring out, you'll be left with 1 and minus 1. So in this particular column, in the second column, it is also common, so you factor it out, exponential minus x, and you'll be left with 5 and minus 5. Is that okay? So you can now discover that our Wronskian of exponential minus x and 5 exponential minus x is going to be exponential x times exponential minus x times exponential minus x, according to indices, will be exponential minus 2x. And when you open this particular bracket using indices, 1 times negative 5 is negative 5, then minus 1 times 5 is minus 5. So minus 5 minus 5 is actually going to give me minus 5 plus 5, and at the end of the day it's a 0. Okay, so our Wronskian of exponential minus x and 5 exponential minus x is going to be what? 0, because this evaluates to 0, and 0 times exponential negative 2x is 0. So since the Wronskian is 0, we can say therefore exponential minus x and 5 exponential minus x are linearly dependent. Is that okay? So what can you actually observe? You can discover that amongst exponential x minus x and 5 exponential minus x, you discover that this second one is actually an integer multiple of the first one. Just like we established in the last tutorial video, that if you discover that one solution is an integer multiple of another solution, then it's actually going to be linearly dependent, and the Wronskian has actually confirmed it for us. When solutions are linearly dependent, their Wronskian will always be 0. So I'll see you in another video where we'll look at another example of evaluating Wronskian, and of course it's actually tied to linear dependence and linear independence of solutions depending on the value that you get from your Wronskian. So don't forget to like, subscribe, hit the notification button, and to stay updated, share this video with your pals and with your colleagues. I hope it has helped you, and I believe it will be of help to them. So see you in the next video where we'll look at another problem. Thank you.